Hello, everyone, and thank you very much for being here. I'm Tommaso Rosi. I'm from the University of Trento in Italy, and I'm also a co-founder of Level Up, which is a startup of STEM education. So today I'm going to talk about augmented reality, serious gaming, and quantum physics. And augmented reality is my main specialization. It's my main area of research as a researcher, and also it's my main contribution to my startup. So, there's many different augmented reality setups that you might use. There's augmented realities simply based on smartphones, which of course is the simplest one, the most not expensive one, and accessible to everyone. But then there's also many other different setups that you may use, more advanced, for example, based on a virtual or augmented reality headset that you put on your head. Then also augmented reality that you can achieve using 3D cameras and projectors, and I will show you some examples. So in general, augmented reality is the idea of showing digital content using the physical world as context. So you kind of mix these two realities. In fact, some people also use mixed reality as a term to refer to this technology. And particularly for physics, but not only, we see a lot of simulations and visualizations when we want to use these setups for education. So we've been using many different setups in the classroom. We are researchers in communication and teaching. So we are really interested in bringing these devices to as many students as possible and see what works, what doesn't, and so on. So here you can see a first simple example of the use of augmented reality through a augmented reality headset. And as you can see here, this other researcher can look around her and see the physical world around her, and also see some digital content and manipulate this digital content. And everything can also be shared on the computer so that everyone else can see what's going on. Other setups might involve the use of 3D cameras and projectors. Now I will show you a couple of examples. So the idea is that with the 3D camera, as you will see later in the next slides, it's possible to have a three-dimensional reconstruction of what's around us, and then we can use simulations to talk about physics. Here you can see another example of what is called a ripple tank. So the idea is that you can use different objects and put them in on the table, and you have this projector above yourself that can create this area in which you can manipulate these objects, and you can interact with the simulation in a very intuitive way. So you see that some objects will be recognized as wave sources, other objects will be recognized as an area of different index of refraction, and other objects will be simply some obstacles. So here, for example, you can see you have a lens, you can have prisms, and so on. So you can really use the shapes of the objects that you want and create any kind of setups that you like. For example, here you see the ultra famous double slit experiment in augmented reality. So since we're really interested in physics education, the main question that we have to ask ourselves is, what can augmented reality do specifically for physics education? So you see, as it happens with many new technologies, all new technologies that we might be interested in bringing to the laboratory, there's always some debate, like, should this new technology somehow replace the laboratory? And of course, this is not our approach, it's not our idea. So it's not a matter of should we use augmented reality or should we go to the laboratory? Instead, our approach is to use augmented reality in the laboratory. Because it is a really high quality measurement and visualization tool, as you will see now. So we are really focusing on this approach, on how to use augmented reality first as a measurement and visualization tool. And I will give you some example now. The first one is about motion tracking, which is my favorite one right now. I'm focusing a lot on this kind of research. So you see, the idea is that using virtual reality and augmented reality headsets, we already have a really good tracking tool, meaning that we are capable of recording the position of the two controllers that we use to interact with, in general, with games, simulations, and so on. So the idea is to use this data and really study motion with this setup. So we can go to the laboratory and we can put the controllers on many different objects and visualize all the additional data that we want. Here we've seen vectors that are velocity vectors, accelerator vectors. You also see here graphs, all kinds of additional information that you can extract from the position. And of course, there's also other experiments that you might do just by move your body. You don't need experimental setups such as these ones. These are examples, but there's many different activities that you might think of simply moving your body. But here are some examples. You see, for example, a cart with a spring attached, so you can study the oscillations of the spring. Then you can also go in 2 dimensions with the 2-dimensional collisions between two objects, or of course you can go to 3 dimensions, but that would be more complicated. There's also the augmented laboratory, which is not based on the headsets, but it comes from the examples that I showed you before, like the Ripple tank, for example. So if you see here, we have the Microsoft Kinect, which is the 3D camera, an example of a 3D camera that we might use. So the Microsoft Kinect, now there's a new version, I think it's called Kinect Azure, something like this. But the original one was meant to be used with the Xbox, and it was meant to be used, of course, for gaming. And now we are starting to see the connection with all of these things that I'm showing you with the actual game jam that you are doing. So the Microsoft Kinect is a very high quality device that was meant to be used to play games. So you could move yourself in front of it, and the Kinect itself would extract the position of your body in order for you to be able to play games. So the main sensor that we are interested in is the depth sensor. So as you can see here, there's this depth sensor based on infrared, and let's see what it shows you. So you see, the idea is that if you place the Kinect on top, for example, of a table here, you can see I'm just playing around with some objects, and you see that there's different colors in a grayscale. So the brightest colors are referring to objects that are very close to the camera. Instead, the color gets darker and darker as we are moving away from the camera. So combining this depth information with also an RGB camera, we can have a 3-dimensional reconstruction Here you see the results of a software that I coded a few years ago. So you have a three-dimensional reconstruction of what the KeyNet is able to see. And let's see why it should be interesting for physics education. So the idea is that we can focus on some specific area, and we can do some simple experiments. And using some very simple object recognition algorithm, for example, here we are capable of recognizing the two spheres that are involved in the experiment. So we place the two spheres, the system is capable of recognizing them, and then we can record some experiment and watch the replay in well, we can watch we can see the experiment in real time and also watch the three-dimensional reconstructions. So we can add additional informations, graphs, again, we can see some arrows that are representing, for example, here the velocity vector and so on. We can also display this in augmented reality using a projector. And so we can display all the information that we want and the tracking information directly on the objects themselves. And as I said, we can also have the replay and watch the recorded data right after the experiment, so that we can comment it with students. So of course, all this data can be exported and have it in different well, analyze it in different software afterwards. And so this was the first example about motion, but of course there can be many others. Another software that we've been working on is some mediated vision. There's this term because sometimes we always focus on the augmented reality part, in which we add additional information, but sometimes we actually might be interested in the opposite process. We might be interested in reducing or alter our vision. For example, we can see the world as a colorblind person might see it. So you can see the color that's are generally represented on the right, so for the common vision, and then you see a simulation of a color-blinded person looking at the same objects. So this can be really interesting when you are trying to introduce the color part in physics classroom, because you really have to separate what is physics and what is the role of perception, because there's a lot of misconceptions out there, and you need some kind of tool like this to actually be really clear where the physics stops and the perception starts. There's also free tools that you can download for your mobile phone. So if you just look for color blindness in the various app stores, you can find really nice free tools in which you can compare the different color blindnesses, and you can display it in the classroom. So that's something that we are really interested in. So you see, for example, here as a person with some kind of color blindness here can really struggle to see what we take for granted that we can see. Then there's a lot of other examples. We could also add external sensors to our setups, but it's not something that I've been really focusing on, so I will just leave it at that. Just to finish this part, I wanted to also add the possibility, of course, of using these tools outside the laboratory. For example, in a science theater event. It's something I've been doing with this performance that it's called an augmented lecture, in which I'm using these augmented reality setups with the headset and color pass-through. So in this way, I can perform real-time experiments in the theater, and Also, of course, I can also add some digital content to do some augmented reality. So everything can be done in real time in the theater, also interacting with students or other people coming to the theater. And this kind of interaction, of course, can be really fun. I've also been using this technology and approach for medicine of the future, which is a performance for theater science that's also that we've been performing around, and it premiered in the Expo 2020 in Dubai. It was a really nice experience. So let's come to the second part of the talk, which is about the serious gaming. Well, it's just actually a very short a very short part. It's mainly this slide because this is the reason why I've been talking about all these different setups, and I've been showing you my my main research area. Because you see, we've been talking about these computers, tablets, smartphones, or 3D cameras, and or virtual and augmented reality headsets. What is interesting in noticing is that all of this hardware is gaming hardware. Of course, computers, tablets, and smartphones can be general purposes hardware, but 3D cameras, virtual reality headsets, and so on are really meant to be gaming hardware. And this is really interesting when we are interested in physics education, because you have three really advantages in looking for gaming hardware. First of all, it has to be high quality, of course, because you can't have a virtual or augmented reality experience or simply a gaming experience with the Xbox if the game is not fun. In order to have fun playing the game, you need a high quality device. And they are very high quality devices, actually. In general, it's true also that when companies are trying to sell you these devices, they are generally even losing money when they are selling you this. So, not even taking account the research part, which is super costly. So, but they do that because they have other ideas in mind. For example, they want to sell you the software. They want you to play games and pay for games. So in order for you to buy the games, they give you super low cost and high quality devices. And last but not least, they're also easily available, because sometimes there's some really high quality devices out there, but maybe they're hard to find. So you need some research to know where to find them. Maybe the suppliers, then they will not give you the same thing. You have to look for an alternative and so on. Instead, gaming hardware is really it's meant to be easily available for everyone. So in general, when you're interested in physics education, especially in the use of new technologies in physics education, I really suggest everyone to always keep in mind gaming hardware and really have a close look to gaming hardware. So even when you're thinking now about the game jam itself, keep in mind that maybe it's also a good place to start to have in mind all the gaming hardware that it's out there, and try to think about if it's possible or not to base a game on this hardware. So the quantum physics part. So there's a lot of simulations and visualizations out there that are free. Here you find some simple references that I will that I briefly show you here with the links, and you have many different websites, really high quality websites with many different resources out there. And I think if you don't really know a lot about it, I really suggest you to have a look, because it might be really interesting for you, whether or not you're interested in using some technology, new technology, simulation, visualization, even just to have an idea of how it is to visualize quantum physics, because it can be really inspiring for you. So this is my suggestion. And because of course, you know, to see, to be able to translate very complicated mathematical formula to something as interesting and fascinating, such as an image like this, which is an image of a quantum orbital of the hydrogen atom, is something that can be really powerful and interesting. There's a lot of art also that can come out of this that can be inspiring for your game. You see, when you just change the quantum numbers, you can see the differences in the orbitals. I think it's really amazing, and there's a lot of information hidden there. And I remember really well when I was studying the first course of quantum mechanics, and I really started to understand more the concept that I was studying when I started using some free visualizations that are available out there. There's also some concepts like the correspondence principle that can be intuitively seen. For example, by again focusing on the quantum orbitals of the hydrogen atom. If you go to really high quantum numbers, you start to see, well, its shape starts to resemble a classical trajectory. So, you know, you have at least an intuitive visualization of the correspondence principle. So why not? I mean, it's out there. And of course, you can actually see more information about, for example, the interference that you have in these orbitals. So in the first two pictures, you see two images that are really similar. It's just that the colors are a bit shifted, and the colors here are related to the phase. So you have the absolute value that is represented by the brightness of the pixel, and then you have the colors that are representing the phase. And when you sum these two orbitals, what you get is a completely different shape, as you can see it on the right, because you have some destructive interference and some constructive interference, so you can have a result like this. So I think it's very fascinating to see it, and maybe can be inspiring for a game. In the first link that I showed you before, which is a website called Falstad. Well, it's a person. It's the website of a researcher that is called Falstad. You have other linear combination, well, superpositions of quantum states. So have a look, because it's really interesting. And also, when you visualize the absolute value of the of your orbitals, for example, or linear combinations of orbitals, you can see the time evolution, and you can see if an object is stationary or non-stationary. So regardless of the colors that you might see when you see the phase, you can see, you can have an intuitive visualization of the difference between a stationary and non-stationary state. And of course, also you can have some link between simulations, visualizations, and the laboratory. There's some very simple and low-cost experiments that can be done, in which you see the quantum jumps that lead to, let's say, some very well-defined colored lines coming from a light source. So you just need a very low cost, object that can give you it can split, of course, the different colors, and yeah, and you see exactly what the quantum jumps are about. You don't have a continuous let's say a spectrum, but you have a discrete spectrum, and you can see it here in the laboratory, and you can also visualize it with simulations and visualizations. Why not? And so if you go on the Falstad website, I wanted also to show you that if you go looking for old versions, so first of all, you see sometimes you have the old version that you might click, then you go to Java version, then you can also click on the source, so you can really see all the source code that is available there. Of course, it's a Java simulation, so might be a bit outdated as a language, but it's if you're a programmer, I mean, it will not be very challenging to translate it to other languages. It's all the main knowledge is there, so it's just a matter of translating it. And yeah, so if you're interested in this kind of approach, have a look there because it's an amazing resource. So this is it. I really simply wanted to give you this, some inspiring thoughts about what can be used as a hardware for a game, or as a software part for some inspiration that might be at the core of the game. For example, why not an augmented reality game with some pretty good software behind the scenes that is either simulating or simply visualizing the data, or can be inspiring even just for the visual part of the game. And yeah, so thank you very much for your attention, and I leave you here also my contacts, the website and the mail, and that's it. For anything that you might be interested in knowing, of course, let me know. Thank you very much, and see you. Bye.